Every time we send a spacecraft to Mars, we risk bringing microscopic hitchhikers along for the ride. Despite NASA's strict sterilization protocols, some Earth bacteria are incredibly resilient and may survive space travel. This raises an important question: are we unintentionally contaminating Mars with life from Earth? If so, could this affect future discoveries of alien life on the Red Planet? For decades, space agencies have worked to prevent cross-contamination between planets. The idea, known as planetary protection, ensures that foreign microbes do not interfere with extraterrestrial environments. Sterilization procedures include baking spacecraft parts, treating them with chemicals, and assembling them in clean rooms. However, some bacteria have been found to withstand extreme heat, radiation, and vacuum conditions. This means that even with the best precautions, a few microbes might still survive the journey. If these microbes reach Mars, they could multiply in underground ice deposits or within spacecraft structures. Studies have shown that some Earth bacteria can survive in space for years. In 2019, Japanese scientists discovered bacteria clinging to the exterior of the International Space Station. These microbes endured extreme radiation, freezing temperatures, and a lack of oxygen. Some researchers believe similar bacteria could survive the trip to Mars and establish themselves there. If they did, they might evolve to adapt to Martian conditions over time. This could complicate future efforts to determine whether Mars ever hosted native life. The Perseverance rover is currently searching for signs of ancient microbial life on Mars. But if Earth bacteria have already made their way there, distinguishing them from native Martian microbes will be challenging. If scientists detect living organisms on Mars, how will they know whether they originated there or came from Earth? This dilemma makes planetary protection more important than ever. Even a small number of Earth microbes could alter the Martian ecosystem in unpredictable ways. NASA and ESA take extreme precautions to minimize contamination risks. Before launch, spacecraft are rigorously cleaned, and microbial levels are closely monitored. However, there is no guarantee that all bacteria are eliminated. Some microorganisms form spores, which can remain dormant for years before becoming active again. If these spores land in an environment with water, they might reawaken and start growing. Recent discoveries of underground water on Mars suggest that some regions could support microbial life. If Earth bacteria encounter these environments, they could survive and spread undetected. This raises ethical concerns about our responsibility as space explorers. Should humans continue sending missions to Mars if we risk contaminating it with life from Earth? Would the discovery of Earth-based bacteria on Mars undermine the search for extraterrestrial life? Some scientists argue that we should halt Mars exploration until we can develop better sterilization methods. Others believe that the benefits of exploration outweigh the risks of contamination. If we ever plan to colonize Mars, the introduction of Earth microbes may be inevitable. But what if Mars already has native microbes struggling to survive beneath its surface? Could Earth bacteria outcompete them, driving them to extinction before we ever detect them? Scientists have proposed ways to minimize contamination risks while continuing Mars exploration. One idea involves sending robotic missions first to study the potential for contamination. Another approach suggests landing human missions in isolated areas far from possible Martian life zones. Some researchers are even developing self-sterilizing materials that could be used to coat spacecraft surfaces. If successful, these innovations could reduce the risk of Earth bacteria surviving the journey. However, no method is foolproof, and the possibility of contamination can never be fully eliminated. The issue of planetary contamination extends beyond Mars. In the coming decades, missions to Europa, Enceladus, and Titan will search for life beneath their icy surfaces. These moons may have subsurface oceans where alien microbes could thrive. If Earth bacteria accidentally make their way there, they could interfere with these pristine environments. This is why planetary protection policies must continue evolving as space exploration advances. Protecting other worlds from contamination is just as important as protecting Earth from returning microbes. Some researchers believe that Earth bacteria might already be on Mars due to past missions. The Viking landers, which touched down in the 1970s, were not sterilized as thoroughly as modern spacecraft. Microbes from these early missions may still be dormant in the Martian soil. If this is true, the contamination process may have already begun decades ago. Future missions could unknowingly reactivate these microbes, allowing them to spread further. If we ever establish a human colony on Mars, contamination will be almost impossible to prevent. Human bodies are home to trillions of bacteria, and maintaining a sterile environment is unrealistic. This means that if Mars colonization happens, Earth microbes will inevitably become part of its ecosystem. Could Earth bacteria survive and evolve on Mars in the long term? Mars has extreme conditions, including high radiation levels, freezing temperatures, and a thin atmosphere. Most Earth organisms would struggle to survive in such a harsh environment. However, some extremophiles, microbes that thrive in extreme conditions, might adapt over time. Recent experiments have shown that certain bacteria can mutate rapidly to survive in space. If they find a way to adapt to Martian conditions, they could establish a microbial ecosystem of their own. This raises another question: could Earth bacteria one day terraform Mars? If microbes introduced to Mars start altering the environment, they might produce gases that thicken the atmosphere. Some bacteria on Earth consume carbon dioxide and release oxygen, a process crucial for life. If similar microbes adapted to Mars, they could slowly change its atmosphere over thousands of years. This could lay the foundation for future human settlements, making Mars more habitable over time. Despite these possibilities, planetary protection remains a top priority for space agencies. NASA, ESA, and other organizations continuously update their protocols to prevent contamination. As we prepare for crewed missions to Mars, the debate over microbial contamination will only grow. Balancing scientific exploration with ethical responsibility is one of the greatest challenges of space travel. If we truly want to discover alien life, we must ensure that we are not bringing Earth life with us. Otherwise, we may never know whether Mars once had life, or if we were the ones who put it there.